501, find mode in binary search tree. Given a binary search tree with duplicates, find all the modes, the most frequent occurred element in the given binary search tree. Assuming a binary search tree is defined as follows. The left subtree of the node contains only the nodes with keys less than or equal to the node's key. Excuse me. Drink a lot of soda. Hey, AP Hacker, welcome again for joining us. Let me finish reading this first. The right subtree of a node contains only nodes with keys greater than or equal to the node's key. Both left and the right subtree must also be binary search trees. So this is kind of, I actually don't, to be frank, I don't always like binaries or just tree problems on Leetcode just because the representation is always a little weird in the examples that they give you. So, but yeah, so, okay. If a tree has more than one mode, you can return them in any order. Okay. So basically, okay. Yeah, so you're given a tree node. For that stuff, I usually like Python. So, but, cool. Yeah, so a mode is just the number that that shows up the most often. And in this case, it seems like you should return all of them if, but they don't have an example about it. But if it has more than one mode, you can return them in any order. And the follow-up is, could you do that without using any extra space, assuming the implicit stack space occurred due to recursion doesn't count? Man, that is a weird follow-up / assumption. I was okay until the follow-up because I mean, I haven't really dug in this problem yet, but if you're gonna do recursion, then there is a cost, and depending on how you do the recursion, like, yeah, if you're gonna recurse something of a depth that's a constant number of times, then yeah, sure, obviously, maybe that's okay, but if you're gonna do like a recursion, like in a degenerate case where you have in a degenerate case where you have like a linked list and you go a recursion down the entire thing, then that's like O of n space, even if you don't really allocate memory for it. And in theory, you would even maybe for bigger n's unroll it into like a queue type things to kind of so that the memory is more or like you don't get into stack overflow and stuff like that. But okay, but let me think. Okay, so the mode is the yeah, so the mode is the number that occurred the most. So you can actually let me see how I would want to approach this. I mean, I think you cannot do better than linear time. Well, I mean, you obviously cannot do. Wait, is that true? I think in general you cannot do better than linear time. Yeah, in the worst case you cannot do better than linear time because if you just have like a tree that has n unique values or a tree with n nodes with n unique values, you will return all of them and you have to scan for all of them, right? There's no way to go around that. I think how I would approach this problem, and yeah, it's supposed to be easy, but and it could. I mean, so I don't know how to kind of describe this problem a little bit because what I'm struggling a little bit is that it's clearly. I mean, it's just a really awkward problem, maybe in that clearly you can calculate the mode very quickly with just a linear scan. Is that true? But I'm trying to already jump ahead to the without extra space part, which makes this slightly trickier. Though it seems like this, except the submission stat is also it's a little lower than I would have anticipated. So maybe there's some one-time thing. It doesn't really describe the size of the tree, but So yeah, so if I were to give a first pass to solving this, I would kind of it's kind of awkward too because I would say there are because given a binary search tree, you can make the assumption that I mean there's like we would have to do some pre-processing to make the tree more efficient so that you could do stuff better than like you could do additional queries better than linear time. For example, it's almost like you want the like let's say you're counting the number of elements that are in this case. Let's say you want to count the number of twos there are, right? So you want to get the leftmost element of the two that shows up and then the rightmost element of the two that shows up. And then if you had pre-processed the tree in such a way that like allows you to kind of like if you pre-process the tree in a way that contains or like tells you how many elements are in the subtrees, then you could kind of do some math to kind of infer that number versus like now like if you do a normal depth first search, you would go 1, 2, 2, and then you still have to go back up to count, right? Yeah, I think the thing I'm also struggling a little bit is trying to figure out what the binary search tree really buys us, other than the stuff that I was saying with pre-processing the tree. Because if we're just going to do like if we want to just do a depth first search with not knowing like we do a depth first search, then we might as well as just do a linear scan, right? And you do a linear scan with kind of some tracking and maybe some and that's kind of n log n. We do some like roughly n log n if you do some like a heap sort type thing or a heap rather, not a heap sort. But yeah, I agree. I also think I have to walk it off. I'm just trying to think. I mean, I think that's the part I'm just struggling against a little bit is like, what does the binary search tree really buys us, right? And I'm trying to figure out a way to exploit the binary search tree in a way to maybe give us linear time. But yeah, yeah, exactly. It is sorted, so like allow us to kind of get the basically the quote unquote lower bound and the upper bound. But the weird thing is because yeah, well, yeah, I mean, yeah, definitely we could use stuff like group by, but definitely maybe I don't know. I'm trying. Sometimes I struggle a little bit with lead coding, at least live, whether that's like in the spirit of doing these things, because I mean, especially in Python, as you know, you probably like 90% of the time are like two-liners, and in Python I'm using iter tools or some sort of like math library or something. So I try to be like a little more explicit in coding this. But yeah, but I think I've talked enough about this, so I think I'm just gonna. But I think yeah, we just have to walk the scan, and then yeah. Okay, and I'm now trying to think of the data structure to kind of keep track of, the data structure to keep track of the mode in general. So yeah, let's say we'll just do a depth of search, and the mode is, yeah. I'm also trying to make sure that I'm doing things in a way that, yeah, I mean, I think I'm also overcomplicating things a little bit. I think you're right. I think I was worried about doing two depth of searches, but I think if I'm respecting things, because I think that what I don't want to do is kind of convince myself that, like, I think we have to like if we really want to do things in linear time, we have to be careful. I think we can definitely like if you're not careful with like let's say if your algorithm is just yeah depth of search for each element depth of search for count. So if you do something like this, we can definitely very easily get into n square territory. And that's what I'm trying to convince myself that we have to do a smarter way where you just do a depth of search where you look at each element maybe once or at most twice. Well, I mean, at least once, but maybe at most twice. But yeah, as you were saying, we get to walk in a sort order. So that, what's it called? In order? Yeah, we could use the in order traversal to get the CS terms out, and that will allow us to kind of generate it. Okay, cool. And yeah. Mm. Yeah, yeah, thanks, John. I think that's true, but I think that yeah, that's what I was saying about earlier about the pre-processing because if we pre-process things in a way such that you know the number of nodes in a subtree, then you can, like you said, discard it. But and I don't have an easy way to draw this, but you can imagine like for example, you have 1, 2, 2, but then like underneath this two, you have a tree of like 10 threes, right, or something like that. And then like well, that means you have step to go by, uh, um, but that means you just have to go deeper to kind of see. But I get what you're saying. But yeah, uh, does it make sense to? Let me think. I'm also just trying to keep it linear in general. I think that part is okay. No, you're right. Uh, I think both of you, AP Hacker and Johnny One Man definitely have better suggestions. I think, to be frank, I probably just overthink this a little bit. I think, yeah, I mean, I think we just need to do an in-order traversal and then just keep track of the counts and so forth, the same way you would just do it in a linear way, except for just a different traversal. So instead of like if you had an array, you would have like for I and root, or like for I and array, and then you just kind of count, right? And the kind of funny thing is, I mean, yeah, and you could even actually amortize that to slightly better, but not to a different complexity class. So that would still be linear. So you're right. So maybe yeah, I definitely overthought it just a little bit for a easy problem. I think we can actually just do a depth of search and then just keep track of stuff as we go. But I think, and this actually makes that implementation a little bit messy, I think. But let's keep track of this. Cool. No, actually, no. Okay, fine. So we'll set up solve dot most. If you go to, let's just say empty array, and then we kick off the recursion with count. I don't know. Yeah, I mean, yeah. Okay. Okay. So now you. Oh. Trying to think what's the cleanest way to do it. Oh, well, we do in order than we actually want to do. Well, I guess it's like the root. What numbers can we do? Well, then, okay, it's not Yeah. Yeah, okay, fine. Maybe I'll just abuse the global state a little bit. Um, okay. A lot of C mistakes. Okay, and then now we count the current one. I would say definitely for if I was doing an interview, I would not be. I mean, I'm still not proud of it, but if I'm doing an interview, I would definitely make some reason about how I'm actually not proud of this, but try to get it right first, and then we'll worry about getting it better. Better. Mm. Hmm. So this should be true already. Okay. And then every and then now we compare it to most. Maybe I could do better actually. Is that right? Something like that, right? Okay, let's test first. Feels a little icky. But, oh, and then am I doing go syntax by accident again? Or, okay, that did not go well. But I think this is on the right track. I just have to let me play around with what do I care about? Okay. Oh, well, I mean, I guess it helps when you return the return value. That would be critical. And so that looks okay. Cool. So that looks okay in this case. I think that's the one thing that I don't like about Leetcode things is that it makes the input kind of a little annoying to to construct. No, that would not really be right. Maybe this is it. Okay, so that's okay. Yeah, and then now maybe I just try very basic things. I think in like I generally like doing more for. Is that even I don't know. That's a valid thing. So okay, fine. But like I said, trees are kind of weird. So okay. So I think I did talk way too much about this problem, but let's see if it's actually. Oh no. Correct. Oh. Huh. None type as. Oh. Do I not check to see if this is none? Oh. Oh, okay. Oops. I guess so. Oh. I thought I tried this. Oh no, I tried it with the no inside. Okay, well. Whoops. No, no, I knew that one. Okay. So yeah, I mean, I think I definitely overdought this one a little bit. Uh, I think to be honest, it just seems like it's a yeah. It just asks you to walk through the array and stuff like this. I mean, I do without using like, an extra space. Uh, yeah, I mean, using the very specific wording, I guess I don't really use extra space except for to hold the result. So, I mean, I use extra constant space. Maybe, hopefully that's okay. But essentially, I don't really hold anything more. I mean, you could maybe if you depending on how pedantic you get, maybe you could say that you could point this to the node so that it's only a reference to whatever instead. But I'm not gonna worry about that much. But yeah, it just seems like now that I'm looking at this problem a little bit more, it just seems like it's an iteration problem that I took way too long with. But yeah, well, I think the case is just like you see, minus the in order traversal. You've effectively this is what you would do with a for loop anyway, right? You just go through the loop and just keep track of this stuff. So I don't know. So that should be okay.